Triptych Algebra. Today we're going to talk about rational expressions, specifically simplifying, multiplying, and dividing rational expressions. Before we get into all of the really good stuff, we need to review two concepts. First of all, we need to review the fundamental principle of fractions, which is a pretty basic principle that means that you can cancel common factors to get an equivalent expression. And we also need to review factoring polynomials. The fundamental principle of fractions states that if you cancel a common factor between a numerator and denominator of a fractional expression, you obtain an equivalent expression. Generally speaking, if you have a common factor, k in this case, you can cancel that common factor and obtain an equivalent fraction. You actually can look at this going in the other direction, saying that if you take an expression and multiply the numerator and denominator by the same non-zero value, you will obtain an equivalent expression. That's a fundamental concept in this section. The second prerequisite to understanding is how to factor polynomials. I won't go into depth in this video. You can see a bunch of different resources online, but I'll show you the factored form of these four polynomials here that kind of give the different ways of factoring. First of all, we have a quadratic with a lead coefficient of 1. These are pretty straightforward. I'll give you a hint here. All I'm looking for are two numbers that multiply to be 6 and add to be 5. Those numbers are 2 and 3. We then know that this would factor into two binomials, x plus 2 times x plus 3. The second version is a little bit more complicated because it's a quadratic where the lead coefficient is not 1. For this, I would use either the AC method or the guess and check to factor it. This will factor similarly to the first one, but it's a bit more difficult. This factors into 3x plus 5 times x minus 1. And again, the difference in the methods of factoring between those two is based on the lead coefficient of a 1 here in the first example and a lead coefficient of 3. In our third example, we have 16x squared minus 25. This is a quadratic without three terms. These can be factored usually using the difference of squares if each term is the square of something. In this case, the first term, 16x squared, is the square of 4x, where 4x squared gives you 16x squared. The 25 is 5 squared. We then can use the difference of squares formula to get this to be 4x plus 5 times 4x minus 5. Finally, in the fourth example, we can't use any one of those techniques to factor this if we tried, but what we can do is factor out the greatest common factor. In this case, the greatest common factor between these two terms would be 5x. So I can factor out a 5x out of both of these terms, leaving me with an x minus 10. So the rest of this video is entirely based on these two concepts. The fundamental principle of fractions, which says that you can cancel common factors between a numerator and a denominator, and the second is how to factor polynomials. All right, here we have three different rational expressions that we're going to simplify using the two tools we just discussed. The first step is going to be we're going to completely factor the numerator and the denominator, and then we're going to cancel any common factors between the numerator and denominator. We will end up with the fully simplified version of our expression. For our first problem here, we're going to factor the numerator and the denominator. The numerator will factor into x plus 2 times x plus 3. This is actually one of the examples that I just previously discussed. The denominator will factor into x plus 3 times x plus 7. Then all we need to do is see if there's any common factor here. We do have a common factor of the x plus 3 between both of these. This gives us a final simplified form of the x plus 2 over the x plus 7. Before I move forward, I want to just really emphasize this point. When it's written in this form right here with these additions and subtractions that are out in the open, we cannot cancel any common factors. For instance, we can't cancel the x squareds here or this factor of 5 or the x between the numerators and denominators there. We can only cancel when we've written our expression completely factored or factored in these forms right here. Then we can apply the fundamental principle of fractions. And the reason is The fundamental principle of fractions is based on this multiplication, this common factor. We cannot cancel ever any fractional or rational expressions when we have these additions or subtractions out here. We can't cancel between terms. In this second example, I will again factor these. The numerator, I can't see of any tricky way to factor this except for factor out the greatest common factor. The greatest common factor in this case would be a 2x. So I would get a 2x times x minus 4 up in the numerator. And in the denominator, this is a difference of squares. This would factor into x plus 4 times x minus 4. I can then now cancel the common factor of the x minus 4 between both of these, leaving me with the 2x up in the numerator and the x plus 4 in the denominator. Finally, for the third version, I'm now going to factor the numerator and the denominator. The numerator is a quadratic with a lead coefficient of 3. I would use the AC method or guess and check to factor this. That numerator factors into 3x plus 5 times x minus 1. And the denominator is another difference of squares with the lead coefficient here of 9, but this is 3x squared, and that is 5 squared to give me 3x plus 5 times 3x minus 5. And lo and behold, as these are all set up to do, I do get a common factor between these two, giving me a final reduced form of this rational expression of x minus 1 over 3x minus 5. One little hint before we move on, you can see that these problems are set up to have these common factors. If you factor with, say, the numerator first, you actually can use that information to intelligently factor quickly the denominator. For instance, when I factor this into x plus 2 times x plus 3, what I'm thinking is, if this is an interesting question, maybe one of those factors down here is going to be either an x plus 3 or an x plus 2. I can often use that information to help me factor quickly. Before we get into multiplication and division, which are very, very similar, let's just recap. What I'm always going to do is factor first. I don't try to cancel anything when it's in this expanded form. I'm going to factor as much as I can so that I can implement the fundamental principle of fractions. The fundamental principle of fractions lets me cancel common factors if I have them between the numerator and the denominator, leaving me with my final simplified product. All right, now here we are multiplying two rational expressions together. These are two versions of what we just talked about. If you remember multiplying fractions, what we would do is to multiply the numerators across and then multiply the denominators. Now this presents an interesting challenge. If we were to multiply x squared plus 9x plus 14 times x squared minus 9, that would include a total of 6 multiplications as we multiply every term of the first polynomial by every term of the second polynomial. We would do then the same with the denominator. The issue would become we would have these massive, difficult polynomials to factor so that we could cancel the common factors. The good news is we have a much easier way of attacking these. What we can do is actually cancel the common factors before we multiply them together. Let's look at an example with some fractions. If we were going to multiply these two fractions together, what we definitely could do first is to multiply straight across to get a 60 over 135 and then reduce that fraction. But we know that's not the fastest way of attacking that. What we can instead do is cross-cancel common factors. So let's do that here. If we cross-cancel the common factors first, or in other words, reduce the factors between the numerators and denominator, applying the fundamental principle of fractions before we multiply, things are a heck of a lot easier. So in this case, for instance, if we cancel the common factor of a 5 between these two, I'll get a 3 and a 2, and I can cancel the common factor of 3 between these to get a 2 and a 3. Then I can simply multiply the resulting the leftover factors here to get a 4 over a 9, which, by the way, is what this would have simplified to in the end, but it's a heck of a lot easier to cancel the common factors now than to struggle with these larger expressions. We're now going to apply exactly the same concept with these slightly more complicated expressions. What we're going to do are cancel the common factors. To do that, what we're going to do is first factor every single one of these polynomials. Then we're going to apply the fundamental principle of fractions. We're going to cancel any common factors between either numerator and denominator. Finally, we're then going to multiply the resulting factors together. If we factor each of these, this first expression right here will factor into an x plus 2 times an x plus 7. Again, the hint is that's because 2 and 7 are the numbers that multiply to be a 14 and add to be a 9. The same thing's going on in the denominator. In this case, it's going to factor into an x minus 8 and an x plus 3. Up here in the upper right, we have a difference of squares. This will be x plus 3 times x minus 3. And in the denominator, this is actually a perfect square trinomial. This multiplies into x plus 7 times x plus 7. I want to emphasize that I'm factoring these pretty quickly, which might be a bit of a struggle for you at this point. It is not a big deal. I highly recommend, though, before you go about simplifying, multiplying, dividing, adding, and subtracting rational expressions, you go back and remind yourself how to factor all different types of polynomials. All right, now comes the fun part. Once I've factored both of these, now I can cancel any common factor between any numerator and any denominator one for one. So in this case, I can cancel this x plus 7 right here with one of these x plus 7s down here in this numerator or denominator. And now I can cancel this x plus 3 right here with this x plus 3 right there. It looks like that is all, those are all the factors that I can cancel. Now what I'm going to do is multiply straight across. What I personally do is I don't actually multiply these binomials together when I multiply them. My final simplified version would look like this. The x plus 2 times the x minus 3 up in the numerator, multiplying across, and the x minus 8 times the x plus 7 that was left over there. I leave it in factored form so that I can look at this and say, I know that there's no way to simplify this because I completely simplified both the numerator and the denominator, and there's no common factor between them. All right, now for our last example, which is division. Division is almost identical to multiplication, except for the one caveat that we need to flip the divisor or take the reciprocal and change this to multiplication. Now that I've flipped the second fraction and changed this to multiplication, I can simply implement the exact same strategy I just used. What I'm going to do are factor the numerator and denominator of this first expression right here. I'll pull out a 5x or factor out the greatest common factor of 5x to get 5x times x minus 10. In the denominator here, I get x plus 4 times x plus 6. This is now a good time to bring up this strategy I was talking about a couple times earlier. The fact that now when I'm going to factor this, if I use the guess and check, my guess is that one of these two are the factors for this. And I'd say another hint is since this 6 is the factor of this constant right here, I'm guessing one of those factors is going to be an x plus 6. And in fact, this factors into a 2x plus 1 times an x plus 6. Again, I could use that to make that factoring a bit easier. This denominator here, all I can do is factor out an x to get x times x minus 10. Now I've done all the work. The common factors look like this. I have an x minus 10. I have an x minus 10 right there. There's that x plus 6 in the numerator and the denominator. And I can actually cancel this factor of x between that numerator and that denominator. It looks like that is everything that can be canceled. To multiply the remaining factors across, I'll get 5 times 2x plus 1 in the numerator. And the denominator, all that survived was the x plus 4.